So let's look carefully at oxygen, right? We're going to talk about isotopes right now. If you look at oxygen, we saw before that oxygen has 8 protons and a 16 atomic mass units. That's the atomic mass. And we said that the atomic mass is equal to protons plus neutrons, right? So 16 is equal to 8 protons plus neutrons. And if we solve for neutrons, we get 8 neutrons are in oxygen, right? Which actually weigh 8 atomic mass units. Let's do another example. And feel free to pause the video if I'm going too fast. Let's look at fluorine. Take a second, try out fluorine. Tell me how many atomic mass units are in fluorine, aka the atomic mass. Right, I want you to tell me the, oops, sorry, that's the wrong. Right, I want the atomic mass of fluorine. I want the number of protons and the number of neutrons. So pause the video, tackle that. Okay, now if we look right over here in this diagram, it has about 19, fluorine has 19 AMUs as the atomic mass units, right? Again, you're not going to see me round, you are going to see me round the numbers up because I'm not going to work with decimals, and I'm okay if you do that too, right? Protons, fluorine's got 9 protons right over here, the red 9. So we said that the mass is equal to protons plus neutrons. 19 is equal to 9 protons plus number of neutrons, and if I solve for the number of neutrons, I get 10 neutrons, which happen to weigh 10 AMUs, right? Because we said before, 1 neutron, you see, remember over here, 1 neutron has 1 atomic mass unit. Let's do one more. Hydrogen. Hydrogen, I want you to tell me what is the number of protons, right? It's got 1 proton. 1 has the atomic mass. And how many neutrons? Well, if it's got 1 AMU, which is the atomic mass, right over here, and it's got 1 proton plus the number, how many neutrons, N must equal to 0. So hydrogen actually has 0 neutrons. And it turns out, so it's got 1 atomic mass, AMU, not the atomic number, don't get that confused. It's got 1 proton, and this is called protium. This is most commonly found on Earth. So let's go on to the next question. Is it possible that hydrogen, it must have 1 proton, right? Because the protons dictate the actual element. Is it possible that hydrogen has 2 AMUs, meaning it has a mass of 2? And that is totally possible. We have what you call deuterium. Is it possible that hydrogen has 3 AMUs? And I'm not going to write AMUs here because you're going to see the notation usually is you have the atomic mass on top and the protons or the atomic number on the bottom. We're going to call this tritium. Right? And it turns out whenever an atom has same protons but different number of neutrons, we call you an isotope. And this is really important. Another way to swing this is to say you can have the same element, which is the same number of protons, but they have different atomic mass numbers. Because what is really determining the atomic mass, right? Well, it's the protons plus the neutrons. Well, the protons are the same, but the neutrons are different, right? So isotopes, you can either say it's the same atom that has the same protons with differing number of neutrons, or another way of saying an isotope is the same protons but different atomic mass. And you're probably thinking, why are we even talking about this? Well, it turns out that deuterium and tritium, anytime you have isotopes that are not commonly found on Earth, meaning less commonly found on Earth, they are unstable. And they typically want to go back to this protium, which is commonly found on Earth, right? And you're probably saying, well, what's the point? It turns out that radioisotopes deal with dating. There are also tracers that use isotopes. For example, this is the structure of glucose, right? And let's say a clinician, someone in the clinic, wants to see how quickly your body takes glucose up. Well, you can't really see anything with drinking normal glucose, but what they actually do is they take one of these, let me get my highlighter, they take maybe a deuterium and they tag it to one of these hydrogens here, right? And now there's a little fluorescent to actually see the uptake of glucose in your body.